Ever dream of turning real-world objects into perfect digital models? Then the Creality Raptor 3D scanner might be for you. It's advertised to have metrology-grade accuracy down to a 0.02 millimeter resolution, and it has 2 blue light scanning modes as well as an IR light scanning mode, which captures objects in full color. And it can scan anything from very small parts to large objects. Whether you're a maker, hobbyist, engineer, or artist, this thing should make pro-level scanning possible. Now, I'm not a 3D scanning expert by any means, but I have done some 3D scanning in the past with some pretty expensive scanners. And back then there were 2 sources of frustration for me. One was with the hardware and the other one was with the software. Now, when it came to the hardware, there were particular limitations with those scanners that caused a lot of frustration for me. So things like the inability to scan certain colored objects, as well as the difficulty with certain environmental light interfering with the scan, or the scanner itself just getting lost while scanning objects, even when using the tracking markers. But according to the advertising, as well as some YouTube videos and live demonstrations that I've seen at some trade shows, the Creality Raptor scanner has apparently solved many of these problems. And I think 3D scanning in general has just come a long way in the last few years. So I'm hoping this is going to be a much smoother experience. So we'll go through everything from the unboxing to the setup, as well as a bunch of sample scans. And finally, I'll take you through the fundamentals of the Creality Scan software. So let's get started. We'll begin by taking a look at the unboxing, and the Raptor comes in one box. And if you've also ordered the scan bridge, that's going to come in a separate box. I'll start with the Raptor Pro, and when you first open the cardboard box, you're going to be very pleased to find a nice hard shell protective case. It appears to be waterproof with a gasket on the inside, and it's packed full of foam, so it should also protect the Raptor scanner from impacts and falls. Inside of the box, you'll find a couple packages of the different scanning marker stickers in 2 different sizes, as well as your warranty card and a brief instruction manual. The scanner itself can be found in the middle pocket, nicely sealed in a bag, and when you remove it, it does feel very nice. It's got quite a weight to it, and the design and the materials feel very premium. Inside of some of the other boxes, this is where you'll find more accessories, such as your power adapter, and it comes with various plugs for different style receptacles across the world. In yet another box, this is where you will find the data and power cable, and if you lift the entire foam lining up, underneath you'll find the calibration board hiding flat on the bottom of the box. You'll want to put this calibration board aside because we're going to need it on the initial setup. Moving on to the scan bridge, this again comes inside of its own box, and when you open the cardboard box, it also has its own carry case, but this one is a soft shell case, and it kind of reminds me of a lunch bag. Nevertheless, it has a whole bunch of pockets where you can store accessories, and when you open the main pouch, this is where you're going to find your Wi-Fi adapter. I love the fact that they've included this, and it will equip your laptop or computer with Wi-Fi 6 if it doesn't already have it. There is also a shoulder strap included for the bag, and inside of this black box, you're going to find the phone mount, which appears to be made out of aluminum, so it does feel like a nice quality component. And some of the other accessories include a USB-C cable, as well as the data and power cable, which will connect the scan bridge to the Raptor scanner. We'll talk about those connections in the setup portion of this video, but finally inside of the last bag is the scan bridge itself. And much like the Raptor scanner, it feels like a pretty serious and solid piece of equipment. Moving on to the setup, the first thing you're going to want to do is make sure that your scan bridge is fully charged. And to do that, you're just going to connect a USB-C connector to the back of the scan bridge, and you'll see the LEDs light up at the front. 4 green LEDs means that it is fully charged. If yours was not fully charged out of the box, that's okay, because we do have other things to do while we wait. And we're going to take the data and power cable that came with the Raptor scanner, and we're going to plug that into the port on the side of the scanner. And this is a USB-C connection, but it does have these thumb screws to ensure that the connection is secure and it does not come loose during operation. Now, the other end of this cable does have a barrel jack connector, and that is going to connect to your power supply that came with the Raptor scanner. The USB-A end of that cable will connect to your computer, and then you can open the Creality Scan software, which you can find for download on their website. And when you first open the software, it will show you an animation of this connection, so it should be pretty clear what you need to do. And the first time you run this thing, you do need to connect it directly to your computer. You cannot connect it through the scan bridge, and you're going to want to do that because likely you will find that there will be a firmware update that will be pushed to the Raptor scanner. And once the firmware is updated, you need to calibrate the scanner. So we can click on the calibrate button and it's going to prompt you to scan the QR code that's located on the back of the calibration board. Now I would recommend that you do this calibration process in an area where you have enough room to move the scanner around the calibration plate and in an area that is moderately well lit, not too bright and not too dark. Now we can start the calibration and just pay close attention to the orientation of the plate. You can use the big round circles in the center to get yourself properly oriented, and on the right hand side it gives you a depiction of the optimal starting position of the scanner for step 1. So as I move the scanner down towards the plate, you can start to see here that it actually shows a nice animation, another depiction of the scanner live where it's positioned. And as I sort of go through those waypoints, which are the gold pictures of the scanner, then it's going to keep cycling through the next position, and you have to kind of hit those waypoints in 3D space and complete all of the steps. Now obviously I sped this up, and I'll be honest, it took me a few minutes to get used to positioning the scanner and fully understanding what it wanted me to do during the calibration, but once I figured it out, I got a 97% score. Now if you don't have the scan bridge, you can skip this next step, but of course I do have it, and so I'm going to attach the mounting plate to the 1/4-20 screw hole in the bottom of the scanner. It seems to be basically the same thing as a camera plate if you've ever used one of those for something like a tripod, and then that plate will slip into the scan bridge, and there are 2 buttons on the side that you can depress to lock the plate in place. On the side of the scanner, you can see that I removed the original data cable and power cable, and I'm going to replace it with this very short version that will get plugged into the side of the scan bridge. And this is, of course, the whole point of the scan bridge. The scanner is no longer tethered to the computer. It's grabbing power from the battery pack inside of the scan bridge, and all of the scan data is going through the scan bridge through the Wi-Fi connection and to your computer, laptop, or other device. And the other piece of magic about the scan bridge and the Creality Scan software is there is this phone mount. So if you do have your computer in another room, like I do, we can plug in the Wi-Fi adapter that came with the scan bridge, and then we can use our phone to get a live view of the scan, and all of that information will be sent to the next room, to the computer. And we'll look at how that's done now with this first example. As you can see, we're going to be scanning this helmet, which I would consider a small to medium sized object, and I have it propped up on some empty rolls of 3D printer filament. Now on the scan bridge, we're going to press the power button, we'll get a solid blue light, and that's going to now begin broadcasting a Wi-Fi connection. And we can scan the QR code on the scan bridge, and it will automatically now connect the phone to the Wi-Fi connection of the scan bridge. Now I can open the Creality Scan app on my phone, click the button in the bottom left-hand corner, and it will recognize the 2 devices as they are now on the same network as the phone. Then on my desktop, because I have the Wi-Fi adapter connected, there's 2 possible Wi-Fi connections. So in the Wi-Fi 6 adapter, I'm going to connect to the Scan Bridge network. And then the Creality Scan desktop application will also recognize the presence of the Raptor as well as the Scan Bridge. Then I can start a new project, select the folder that I want to save it, and click on the wireless display button. And this will bring up another QR code on your computer screen, which we will need to scan with our phone. In order for this to work, you will need to allow access to the devices on this network. Windows will likely prompt you for that. And now we can finally scan the QR code with the Creality Scan app on our phone, and it should establish a connection. And finally, using the phone mount bracket that came with the scan bridge, we can attach that to our phone. It just clamps to the outside and then magnetically sticks to the back of the scan bridge. Now this is quite the connection process, and it will take you a few times to get the whole thing memorized, but I'm actually surprised that it works as reliably as it does. I've never had a single connection issue so far. Now you'll see that I did press the preview button and nothing is coming up, and it's saying not enough markers. Right now I have the scanner in blue laser mode, and one of the things you may have noticed is that I did not attach any of those little dot style stickers to the helmet. The blue laser mode needs to use those markers as reference points to help keep its position. So instead we're going to flip over to the infrared mode and try that for our first example. Now just to be clear, you still can use the markers in infrared mode to track the position, But for this example here, I'm going to show you that it shouldn't really be necessary. Now, if you do have an object that does have a lot of repeating geometric patterns, even this helmet, although there's no repeating patterns, it's kind of just round and a bit ambiguous. The scanner might have some issues picking out points that it can use as reference points to help track its position. But regardless, I'm going to try it as is. Now, on the left-hand side of the screen, you can see that while we're scanning, there is a bar that shows you if you are positioned too close or too far from your object. It does take a little bit of practice in getting used to working your way around the object at a very consistent distance. Now, what would help, and is a very popular solution, and we'll get to that a little bit later in this video, is having some kind of a turntable where you can spin the object around instead of you having to move around the whole thing. Now, at some point here, I was satisfied with how much of the helmet that I scanned. I was really only interested in the front because I wanted to build a visor off the front of this helmet. And when I was done scanning, I could just press the stop button on my phone, and through the magic of the app and the network connection, the scan finished. And this is when you get into the post-scan processing. So on the right-hand side, there are some tools where you can edit your scan. For example, with the selection tool, you can manually select portions of your scan, such as these floating regions, and I can just press the delete button. And so I'm basically going to delete anything towards the mid and rear of the helmet that I'm not going to need, because again, I'm going to be designing a visor around the front. Now, there is a button that says one-click process, and that should clean up the scan and then provide some sort of a mesh. Now, in the infrared mode, you also get a texture, so you can see after I've clicked one-click process, there's actually a full color representation of the helmet. Personally, for my use, that's not something in this example that I'm particularly interested in, but I thought it did look pretty good. And overall, the automatic cleanup process did a nice job of creating the mesh, and even the mesh itself can be edited. So you can see on the feature tree on the left-hand side, I've got the mesh selected, and similar to what I did with the raw scan, I was able to just select regions and delete it. And then in the top right-hand corner, we can export our model, and we have several different file formats that we can export as. And depending on the CAD program that you plan on doing your 3D modeling in, you'll have a preference for the type of export. In some cases, you'll want the point cloud, and in other cases, you'll want some sort of a mesh. You can even export it as an STL file. Now, when it comes to modeling around your scan, this is something that goes far beyond the scope of this video. Using the scan data, I was successfully able to create a visor model, and then I sent it off to the Creality K2 PLUS for 3D printing. And I printed the first version in PLA, and the fit was almost perfect. I only had to make a very slight modification before printing the final version in carbon fiber PLA, which, if you've never printed in before, gives you a beautiful matte black finish. And here I'll show you on the helmet itself why I needed to make a very small revision. So when looking at the first prototype in the gray PLA, just around the temples of the helmet, the fit was ever so slightly too tight. And this wasn't due to the scan itself being inaccurate. I was just overestimating how tight I needed to make the model to the helmet itself. And so you can see when I compare the two directly, it was just a tiny, maybe 0.5 millimeter on each side that I had to shave off of the final model to get a really nice fit. Now, if I didn't have a scanner, this would have taken me many more iterations of printing, and I probably would have had to go back to the cardboard template method. So I'd say that only having to do one revision was a huge success to get such a nice fit, and I was just able to mount this directly to my helmet with some double-sided tape. And although this isn't a huge and complicated project, this was something that I really did enjoy doing because it's very functional, and it made a huge difference for me as I wear this helmet while I'm on my electric scooter commuting into work. It does a fantastic job of keeping the sun out of my eyes, and if you guys are into electric scooters, I've got another video coming up in the near future that you're not going to want to miss. But since we're on the topic of transportation, one of the other very popular applications for the use of a 3D scanner is scanning automotive parts. And in this example here, I've got a rear bumper, so the lower portion of the rear bumper that I want to scan. Now in this example, we will be using the markers because I want to use the blue laser mode. And the rear bumper of a car is a fairly large part, so I'd put 2 full sheets of stickers on the bumper, and that would be a total of 100 of these marker stickers. And if you haven't used them before, you want to avoid placing them at regular intervals. You do want to place them in random positions all over the thing that you're trying to scan. Now, it's not clear to me how many markers need to be visible to the scanner at any given time for it to maintain tracking, but I personally tried to place them, let's say 1.5 to 3 inches apart from one another. And this seemed to work very well for me, as during the entire scanning operation, the scanner never really lost its position or tracking for any significant period of time. Every once in a while, it would just blip out and then pick back up exactly where it had left off. At worst, it might happen for 1 to 2 seconds before it would figure out where it was again. Now, in order to get all of the details of the lower portion of this bumper without, of course, removing it from the car, I did have to rotate the scanner, and at one point I had it pointed completely upside down. And this is where the scan bridge really comes in handy, because obviously if I had it tethered to the laptop or a computer, having all of those cables attached would be a real pain while trying to scan something like this bumper. So if you're looking to pick up the Raptor for automotive use, I would highly recommend getting the scan bridge so you are completely free to move around. Now you can also see here that there are blue sections and yellow sections. In the bottom left hand corner, there is a quality map. You can click on that to expand, but really what you're shooting for here is a nice looking blue model, at least in the areas where you want the best and highest level of accuracy. So you can see as I go over certain sections of the bumper for a second, third, fourth, or even fifth pass, some of those yellow sections are going to turn blue. Now I've sped this screen recording up, so it probably looks a little bit jerky, but I was experimenting with different scanning techniques. So I was trying long and smooth motions as well as short and jerky back and forth motions to see what would result in the best scan possible. In the end, I was able to get most of the bumper to turn a nice blue color before finishing the scan. And immediately, the difference you can see here between this one and the helmet scan is that right away you can see that there are a bunch of markers present in the actual scan result. Right now we're looking at the raw scan as I go through with the selection tool and erase areas that I'm not interested in. Once we go through a bit more post-processing, those stickers and markers will disappear. And one way to do that is just to simply go with the one-click process. And quite frankly, with all of the scans that I've done, the one-click process has worked great for me. Perhaps if I get into scanning more complicated models or something with more intricate geometry, that's when I may have to work on the mesh a little bit more manually, but I was surprised at how well the automatic post-processing did work. Now this scan is quite a bit bigger than the helmet, so when I had the mesh selected in the feature tree, I could edit that mesh, and you get a few different tools in here. And one of them that I find to be the most important is the mesh simplification. If you've worked with other scanning tools or worked with meshes in general, this may also be known to you as decimation, and essentially you're reducing the number of triangles that make up the mesh. This will significantly reduce the file size, and depending again on what type of CAD program that you're going to import this mesh into, because in a lot of cases the smaller file size and less triangles that the CAD program has to deal with, the faster that it's going to run. And so in my case, I exported this as a .ply format file, and then I was able to create these little diffuser fin extensions for my rear bumper. Now, had I been interested in producing something like a full-size rear diffuser, all of this scan data would have been perfect for that, but in this case, I just wanted something very small and subtle looking. And as I'm rotating this model around, it's a bit of an optical illusion, but you can see some of those red diffuser fins actually protruding into the backside of this mesh. I tried to create those surfaces to hug the mesh data as close as possible, as I wanted a really precise fit. Then I exported my fins, brought them into Creality Slicer, and I'm going to be printing these in some carbon fiber ASA. I went with ASA despite it being more difficult to print because of its ability to withstand conditions outdoors, because this will be going on the outside of a bumper. I'm again using the Creality K2 PLUS to print these, and one of the beautiful things about the K2 PLUS is it does have a chamber heater. Creality's slicer did have some presets for the ASA material, but I did find that the internal chamber temperature was too low. I believe the preset had it at 35 degrees Celsius. I bumped it up to 50 degrees Celsius, and that got rid of all of the warping. You may have also noticed when I had sliced the file, I did include a generous brim and some mouse ears because these fins do have some very sharp points, and those sharp corners are probably the worst thing that you can have for warping, but they were part of the aesthetics of the design, so I couldn't get rid of them. But with the increased chamber temperature as well as the brim and mouse ears, you can see how well these things turned out. Absolutely zero warping. Carbon fiber ASA looks amazing, as similar to the PLA carbon fiber, you get a nice matte black finish, and best of all, the fit was bang on. And you can see me test fitting the pieces here. I do have the piece in one hand while trying to hold the camera in the other because it was a very awkward angle to film. So I apologize if my hand was shaking a little bit, but you can see just how nice the fit was. And maybe it's a little difficult to appreciate through a YouTube video, but the surfaces of that bumper were not at all simple curves. Even in these very small regions, those curved surfaces would have been near impossible to replicate using the traditional methods of cardboard templates. And this is obviously just a very small example, but again, going back to some of the most popular applications for these kinds of scanners, it's no wonder that automotive use is going to be one of the #1 applications. Having a scanner like this gives you the incredible ability to accurately model around all of the organic curves of a vehicle. And also with the laser type that the Raptor uses, I was able to scan this black surface without the use of any scanning spray. If you're not aware, some scanners do require the use of a scanning spray to change the color of the surface from black to something lighter, and having to spray your object is just a whole other step that is inconvenient and can be very messy to clean up afterwards. I've had to do this in the past using older scanners, and believe it or not, Gold Bond foot spray works great for this. And although it actually kind of smells nice, it is a real pain to clean up. So I'm just happy I didn't have to do that. And while we're on the topic of convenience, if you plan on scanning a lot of small to medium sized objects, I would highly recommend either building or buying one of these scanning turntables. And this one here I saw at the Creality 3D scanning booth at Rapid TCT earlier this year in Detroit, and it was being demonstrated by Yuri, and that's because he created it himself. He was demonstrating its use with the Raptor 3D scanners at the booth, and Yuri and I had connected at the show, and we've been in touch ever since. And Yuri was kind enough to send me one. And you can see that it's pre-populated with all of the markers, and it's got a lot of cool features on it. For example, if you're scanning taller objects, you can remove these attachments from the side. I'm not sure what their technical name is, I just like to call them towers. And they have various brass threaded studs on them. And you can thread those into the female threaded inserts on the platform. And this will now give the scanner some reference markers that are higher up in the event that you're scanning something taller. Now, for this example, I'm going to be scanning something flat, so I'm not going to need this. But you're going to see how easy the turntable makes scanning objects like this without having to put any of the stickers right on the object itself. So I have the Creality Scan software set up using the blue light for a new scan, and I'll just go ahead and press play on my phone using the scan bridge. And right away, the Raptor scanner picks up all of the markers that are on top of the table, and it recognizes the tool that's sitting on there without the markers. And the thing that I love about this is that you now do not have to work your way around the object. You can just use one hand to hold the scanner, and in your other hand, you can spin the turntable around. This makes it extremely easy to maintain the optimal distance between the scanner and your object. Without the turntable, I would have to maneuver my way around the object and walk around the table that it's sitting on, and this can be tricky, especially if you don't have the wireless scan bridge. If your scanner is tethered to your computer or laptop with the original cables, the turntable will be an absolute lifesaver for you. Now, in addition to the turntable, for this final example, I'm going to show one more feature of the Creality Scan software, and we're going to do a second scan where I've flipped the object over. Not all objects can be captured in a single scan, so again, you can see that I've flipped the object over. Now, this object is more or less the same on both sides, but it does have some minor differences, and the geometry of the object itself has a lot of round corners and edges, and it would make it very unstable and difficult to stand up on one of those long edges and capture both sides in a single scan. So it's still a good candidate to lay down flat and then scan on both sides. And once we're done with scanning both sides, we can go back into the Creality Scan software, and this is where we now have 2 separate scans in a single project. And I can go through the familiar process now of cleaning up each of those scans individually. I've obviously sped this process up on video just to get to the point here, because at the end, once you're done cleaning up both of those scans, you can select both of them on the feature tree on the left-hand side, and we can click on the Fusion button. And for now, I'm just going to leave all of the default settings in there and click on OK, and then it's going to fuse or clean up both of those objects. And this is where we can move on to the mesh processing, and in here we can have both of them selected and then select alignment. And the auto alignment is very good at aligning 2 of these scans together. However, if it does have some difficulty, there is a manual alignment where you can manually select different features that you think would help the software to align the 2 scans. But for now, we'll stick with auto, and I'll just click on align. It'll align them perfectly, and then I can click on exit. Now, once they are aligned, you can see that there are parts of the mesh that look like they're overlapping or overshooting, and I can further clean up the mesh. So I can click on each of those original scans again, and then I can go in here and just manually edit them a little bit further. So again, I'm using the selection tool, selecting the areas that are kind of sticking out or overlapping, and then I'll just press on the delete button. And once I'm happy with what I've done, I'll click on the little check mark at the bottom, and that will confirm the changes to the scan data. And so again, I've sped up the process here. To be honest, it is a little bit tedious, but if you are careful with what you're doing, the end result will be worth it. And after a bit of work, you can see that this is the final result. So I've got both scans lined up, and I don't have any areas that are sticking out, and I can't see any floating regions either. So at this point, I'm ready to create the mesh, so I've clicked on the meshing button. This will bring up a bunch of options to control how many triangles the final mesh will be made out of, whether or not I want to smooth the mesh, remove any sort of isolated triangles or parts. You can also remove spikes and fill small pinholes. Generally, I really like to reduce the amount of triangles inside of the model. From my understanding, this will simplify and potentially reduce the resolution of the model. However, once you export the mesh and you're working with the 3D model in your favorite 3D modeling software, it's probably better to reduce the number of triangles to make it a lighter model, and this generally speeds up the rendering in whatever software you're working with after Creality Scan. Now, in that previous menu, I was only able to go down to about 200,000 triangles, and so you can click on the mesh on the left-hand side, click on Edit, and then come into the Edit menu, and there are further tools to reduce the mesh triangles, so that would be found under Mesh Simplification. You can drag that slider to the left-hand side to reduce the number of triangles, and it does give you some indication of how large the file size will be as various file types such as STL, OBJ, or PLY. Then you can preview your changes, and you can accept them by pressing OK. And so now I have my mesh, and I think it looks fantastic, and I can use the button in the top right hand corner, Export Model, and I can choose to export this as an STL, an OBJ, or a PLY. So I hope that example gives you a pretty good idea of how you can use the alignment tool inside of Creality Scan, and also the value of having a 3D scanning turntable. So if you guys are looking for a turntable like this, go support Yuri. I'll put links in the video description down below. He's currently in the process of bringing a ready-made solution like this to the market, so I don't have a link to the actual product just yet, but I'll link to his socials where he can keep you guys updated on the progress and where you'll be able to find the final product. And speaking of products, don't forget that the Raptor scanner is not the only model that Creality has. Go check out their website, because earlier this year at that Rapid TCT show, I also had my full body scanned by the Creality CR-Scan Otter. And I know more recently that they also just released their new Sermoon scanner. And depending on your application, you'll probably find that one of these models suits you better than the others. I'll put some affiliate links to the various scanners in the video description down below, and you can use those links. It costs you nothing extra, and it goes a super long way to helping to support this channel. So that covers the basics of the scanner, and in the introduction to this video, I had mentioned that I had done some 3D scanning in the past, And some of the main pain points I had with even multi-$1,000 scanners was the poor quality of the scan output due to a few conditions such as the color of the object, as well as some environmental lighting conditions, or the scanner just getting lost in general while performing a scan. But it seems like the Creality Raptor has solved many, if not all of those issues, and the only surface that it might still struggle with would be a glossy black surface, in which case you could use a 3D scanning spray, and we talked about that earlier in the video. So the 3D scanning process with the Raptor was very easy. Even the software to get to a usable mesh was also very simple and straightforward. The wireless scan bridge is the ultimate inconvenience in terms of accessories for the Raptor scanner, so I would highly recommend, if that's within your budget, you can get that. So when it comes to the hardware and the base functions of the software, I really have no complaints in this case. The thing that still drives me crazy about 3D scanning right now is the post-processing after creating the mesh. And this isn't limited to the Creality scanners. This goes for all of the brands that are kind of within this price range until you get to industrial scanners that cost 10 times as much. Those ones come with some very advanced software suites that allow you to do more advanced and complicated things. Now, I don't expect Creality to develop one of those very high-end software suites and include all of those crazy features, but just some kind of basic things like being able to take the mesh or the scan data and create planes or axes, or being able to edit the origin so that when you import the mesh into a parametric modeling software like Fusion or SolidWorks, it makes it so much easier to work with. It just really seems that a lot of the focus in terms of advancement and development has always been on the hardware in recent years, and we're at the point now where we have fantastic resolution, but I'm just hoping that in the future we can focus a little more on the software and get it to the point where we can have some of those basic features to make the post-processing easier. And then of course, when we bring it into a third-party software for modeling around the mesh, we can get that to a point where it's so much easier to use. But let me know what you guys think down in the comment section below. Perhaps you guys already have a third-party software solution that can do all of this very easily and very quickly when working with mesh bodies. I hope you guys enjoyed my take on the Creality Raptor 3D scanner. Don't forget to check the links in the video description down below for everything that I've shown in this video. And of course, don't forget to hit that subscribe button, because in the future, I plan on using the Raptor scanner for some projects that I will be featuring on my channel. Thank you guys so much for watching, and I'll see you in the next video.